So let's start with the first one. So we have J1 equals 1, J2 equals 1. So big J is going to equal what all the way down to what?
The sum to the average?
Sum to down to their difference. So the sum is going to be, Jeffrey, 1 plus 1.
Oh, okay, you're looking at it. I was like, 1 plus 1.
So you're going to 2 all the way down to their difference, which is 0. Okay, then you fill in everything in between, because it's just J plus 1. You sum them, subtract 1, then you subtract 2, then you subtract 3. So you pretty much just number them down here, right? There's only 1 and you're done. Okay, then for each one of these, you're supposed to write the m sub j values. So for 2, m sub j would be 2 all the way down to negative 2. And then you fill out all the numbers in between, right? So you'd have a 1, a 0, and a negative 1. And then for a 1, Alyssa, you'd have for m sub j's,
It would be from 1 to negative 1?
yeah, 1 all the way down to negative 1. So you'd have 0 in between. All right, those are our m sub j's.
Oh, I see. Oh, sorry.
M sub j is 4, 2. Or do we have to do each number?
You have to do each one, right? Because each j has its own set of m sub j's. So for 0, m sub j would just be 0. Okay? Now we don't have to have whole numbers. Whoop. It's going to get longer. Okay. Now I got for B. You'll like this, though. It's kind of fun when you get used to it. Okay. Their sum down to their difference. Big J here is going to be 3 halves all the way down to a half. Okay. Is there anything in between?
1. No. 2. Yeah, 1. Yeah, 1.
So 3 halves minus 1 is 1?
So there's nothing in between?
There's nothing in between. Because you subtract 1 from 3 halves, you have a half. So you're done already. Get it?
Subtract 1 from, oh, okay.
Right? Because we summed them, and then we have to sum them and subtract 1. Well, we're done already. So then the m sub j's (3 halves) all the way down to negative 3 halves. Okay, is there anything in between? 1 half. And perfect, you got it. And for the 1/2 term, the 1/2 j, 1/2 all the way down to, is there anything in between? Right. We wrote the number, and then we subtract 1. We're already down to negative 1/2. So yeah. Okay. So so you do D, you do C, and then we'll do D together. Do C, then we'll do D together. Hmm? You don't need a calculator. My goodness. Jeez. If you really want a calculator, I'll give you one. I've got plenty. Jeffrey's too proud. He's not gonna grab that calculator. Now, when you're doing this, if you're using a calculator, you don't use decimals. Everything stays in fractions. So that's why the calculator really doesn't help, I don't think, because
Yeah, it does.
you can convert to fractions on your calculator?
I did 2 plus 3 halves to be 0.5 in fraction.
Wow.
Shabam.
You still think these are better?
Yeah.
Yes, I do.
Those make me
Because I'm forced
I'm
forced to think. Well, you shouldn't have to. 3 halves minus.
Complicated things like I don't know how to use this calculator. So we don't know.
All the way down.
Look, this is 4 halves. 4 halves plus 3 halves is 7 halves. I mean, how hard is that? 7 halves minus 3 halves is 4 halves.
Life gives
It's
you a calculator.
faster.
You use the calculator, life gives it to you.
Oh, there's so many SFJs.
You're no longer my favorite student.
Work smarter, not harder, Dr. Smith.
Okay, whatever.
Yes.
So did you get 1, 2, there's 4 of them, right? 7 halves, 5
Yeah.
halves, 3 halves, 1 half.
So the first MJ, MJ. Oh, minus 1, so 5 over 5 halves,
So it's the same thing all the way to negative?
3 halves. Oh, yeah.
It's not torture. It's fun. Life is an attitude. So if you tell yourself you're having fun, you're having fun.
So much fun. This is great.
You got to do it more than once.
5 over 5 halves just goes from 5 halves to the negative 5 halves right here.
Yeah. It's just the same
They just
thing,
keep,
but
like,
smaller.
reducing.
Yeah.
Look at you're a freaking professional now.
Calculators.
Oh, wait, what is that for?
L1.
Oh man, he threw me in a J3. Oh.
So everyone done? Okay. So on D, it's gonna get long with the homework too. So what I want us to do is at least what I've found is easiest to do is to make this little table. And what I do is, let's see, I had in my table, I don't have all of them. I'm gonna do a little coupling first. So, but in my table, I'm gonna fill out J3, and then I'm gonna couple it to, and then I'll couple my J3 with what I end up over here. Well, you'll see. You'll see. Then let's just make the table first. And you'll see what I think.
It's gonna be a big table.
Yeah, it will be. Okay. So what I want to do is I want to couple, because look at the rule only lets you couple 2 things at a time. So what we're going to do is we're going to couple 2 of these. We'll couple them, get our answers, and put them in the table. So our J3, which is a 1 here, I'm just going to put it in this table here. And I'm going to get a J, and I'll couple those 2, right? Oh, I forgot sorry. J is the final answer, isn't it?
Yep.
So I need a J prime. Okay. So what I'm going to do is I'm going to couple these guys, couple little J1 and little J2, and get not our final answer, but J prime. Okay? And then we'll put J prime in the table, all those numbers, right? All those numbers, we'll put them in here. And then we'll couple them. So we'll couple each J prime with J3 and get our answers. And then from each answer, we get the M sub J's. So, all right, well, whether you see the big picture or not, it's easier if we just do it. Okay? So let's first just couple. It doesn't matter which 2. Let's couple these first 2. you get J prime to be what all the way down to what?
2, 1, 2.
2 all the way down to 0, right?
Why?
Because we're just going to couple these two.
Because it's 1 plus 1, then it's 1 minus 1. So
Oh,
we
right.
do-
Yeah. But those aren't our final answers because we still have to couple J3. So that's why I call it J prime. So let's put those J primes in here. You've got a 2, a 1, and a 0. And I'm separating it out this way. So how you read this table is that if nothing is written, that means that J3 is right here. Right? J3 is a 1. I mean, you can put 1s all the way down. It just so that it's going to look uglier when you get longer problems. So I like just leaving it like this. But that's just me. Okay. Now if I want to get my J's, okay. Now I can get my first final J's here. If I couple J3 and J prime in the top row, I'll get 3 all the way down to 3 all the way down to
Oh, to 1.
1.
Oh, yeah.
Right? Then I have to write an M sub j, a set of M sub j's for each of those j's.
Oh, man, this is an end.
So my first set would be
3 to negative 3.
3 to negative 3. Right? 2 all the way down to negative 2.
That's not going to go in this little box.
1 all the way down to negative 1. So that's why these, it's kind of like this, I guess, is how it's visualized, right? So now you have to write the M sub j's for j equals 2. Write the M sub j's for j equals 1. And I did that. I did that. Okay. Now you go on to the next one. The j would be 2, 1, 0. Then you write its M sub j's. Then the last one would just be 1. So
0. No,
okay. Then there will be another set of rules that we'll talk in class about how to write term symbols out of all this, how to pick lowest energies and all that kind of stuff. So what we are doing is we're coupling, well, might as well tell you, we're coupling angular momenta and we're giving all the possible energy states is what we're actually doing. And it's through Clebsch-Gordon coupling. So there's a bunch of them for you to do. So enjoy. This is your homework. You can get it knocked out before you even go, right?
You want us to put it all on the table?
I got a lot of paper here. I brought a bunch of paper here so that you can